So let's talk about exemptions. So there's a lot of seniors that need to know this week, and I should have a report tomorrow, so I know who's exempt. So I'll be emailing that out probably no later than Thursday. I hope to get to it tomorrow. I just depends how quickly and how early in the day they get me the report. Uh, Going well. IT checking in on me since I have a loaner computer. Sometimes there's problems. Justin, he knows me by name. But let's talk about exemptions. So to be exempt from the final, and this is, of course, for all your classes, because you can exempt all your finals in the spring. In the fall, there's certain ones you have to take, English and some of those courses. To be exempt, number one, first and foremost, no more than 4 absences in advisory class, which is the class after this one, advisory. Hopefully you have not had more than 4 absences, because if you have had more than 4 absences, you have to take every final. So advisory counts for every class. You have too many absences. So if you have more than 4 absences in advisory, I don't even have to look at anything. I just know, oh well, you're not exempt. I don't even have to check. But let's assume that you've kept the absences down. You've been attending advisory. Great job. Then to be exempt from this class, no more than 4 absences in here. This next part's changed, and I want to make sure I explain it clearly because it was a little confusing for teachers when it first came out. We used to say no more than 4 absences and no more than 4 tardies. Now you can have more than 4 tardies. You can have up to 8 tardies. But if you have more than 4 tardies, it also counts against your absences type of thing. Like you can have 4 absences and 4 tardies and be exempt. If you have 5 absences, it doesn't matter how many absences, it doesn't matter how many tardies, you cannot be exempt from 5 absences. But you could have 5 tardies if you only have 3 absences. Adding them together can't be more than 8. If you have 6 tardies, you have to have only 2 absences. 7 tardies, 1 absence. If you have 8 tardies, you can't have any absences. So you can have more than 4 tardies, but it has to add to your absences and be 8 or less. So that's the best way I know to explain that. 5 tardies means you can only have 3 absences. So that's new. We just changed that last month. That's new. The other things, once we get past all the absences and tardy stuff, no missing assignments. That gets people sometime. Now, in this class, when I look at this, wow, I see grades from one into the other. Very few people are missing assignments. Very few people are missing the assignments. So, but if you're not sure, when we go to the grade screen in Buzz, you should go to the grade screen in Buzz and look at the grade column, make sure there's no zeros over there that you didn't turn something in. Now, if you got a 0 because you turned in AI, well, maybe you want to redo that. So no missing assignments. That's a big one. And then if you have no missing assignments and absences and all the other stuff, your grade has to be 75%. And again, that's not an issue for if you've got everything turned in, your grade is probably over 75% because very rarely do people do that poorly in my classes that they've turned everything in and they're barely passing. Generally, if you're barely passing or not passing, it's because you have missing assignments. That's been the rule for the 5 years I've sat at this chair. Well, maybe not this chair. This chair was new this year, but sat in this corner of the room, I guess. So yeah, and then the last one is no fees or fines, but this class doesn't have fees, so that's not an issue. So that's it. Make sure your absences. You check on that first if you want. Hopefully, you've been doing good with attendance, but no missing assignments, 75% grade. Check those things because that's pretty big. I don't want you to have a 93 in the class and have to take the final because you didn't turn in something last month. So, all right, we've gone over all that. Let's take a look at what this is. This is our last lesson for seniors. The rest of us are about finished as well. Seniors, this is it. Let's take a look at it. Let's go to our grade screen as usual. I say, go to grade screen, make sure you don't have any missing assignments. Check all these assignments all the way down. But this week, we are on our last lesson under the rational functions unit, graphs of rational functions. This is the last lesson for seniors. Next week, I've got something kind of different for the rest of us. For those of you who are not graduating this week, we've got a different assignment. And then our semester final, which I posted that in our Google Classroom on the front page. Our final is scheduled for Tuesday, May 26th. So that's 3 weeks from today at 9:15 a.m. here in our class. So, yeah, our final is 3 weeks from today for non-seniors. Seniors, yours is next Tuesday if you have to take it. Let's look at the 8.07 lesson on graphing rational functions. I've got Desmos open here. I need to cancel what I was doing on that. I was doing graphing sequences. Okay, here's our scenic overlook. So rational functions, remember that's where you have a polynomial divided by a polynomial. 3x squared minus 2 over x squared plus 2x plus 5 or something, Polynomials with no common factors. The graph. So the y-intercept is the value of f of 0. If you put f of 0 in there, that's where it's going to hit the y-intercept. The x-intercepts are the zeros of the numerator. The numerator, the p of x, whatever's on top. The solutions of the equations p of x equals 0. The vertical asymptotes, if any, are the zeros of the denominator. So we've talked about all these asymptotes, wherever q of x equals 0. Remember, the horizontal asymptote is the value where f of x approaches as x increases or decreases without bound. When it goes up or down, whatever x it's approaching, and determining the behavior of the graph in between and to the left and the right of each x-intercept and vertical asymptote is crucial for describing the complete graph of a rational function. For example, 5 divided by x plus 1. What do we know about that before we even open Desmos? Well, the y-intercept is 0, 5, because if we put in a 0 for x, you end up with 5 over 1, which is just 5. So we know that's the y-intercept. There is no x-intercept because that's the solution to the equation p of x equals 0, 5 equals 0. So there's no x on top of the numerator, on the top of the fraction. It does not ever touch the x-axis. In fact, that is a horizontal asymptote because the denominator is of higher exponent than the numerator. We have an x to the first in the denominator. There is no x in the numerator, so the denominator is higher, so the asymptote's y equals 0. And since x plus 1 is in the denominator, we know we have a vertical asymptote at -1. So let's actually graph this and take a look at this. 5 divided by x plus 1. There it is. Oh, I'm zoomed way out. Let me zoom in here. We talked about how it does not have a 0. Look, it does not touch the x-axis. That is an asymptote at y equals 0. We said there's an asymptote at y equals -1. Yes, as x is approaching infinity, it's getting close to -1. As it approaches negative infinity, it's getting close to -1, but never touches -1. And we said that the y-intercept was going to be at 5. And there it is. There's the y-intercept at 5. So all these things we talk about, the y-intercept, no x-intercept, the vertical asymptote, the horizontal asymptote. We would know that by looking at the equation. We can prove that by actually looking at the graph. Test your skills. Determine the y-intercept, x-intercept, vertical asymptotes, horizontal asymptote. This one is almost identical to the one we just looked at. There's one change. It's x minus 1. So what does that change? The only thing that changes, because it still has the same horizontal asymptote, everything, it just changes the vertical asymptote to be at x plus 1. X equals 1 instead of -1. Look, we'll change this to a negative. The only thing that happens is it moves it over to x equals 1 as the vertical asymptote. Everything else is exactly the same because nothing else is different. We still have a denominator that's a higher degree than the numerator. We still just have 5 on the numerator up there. Let's look at perhaps this one. And I can put a piece of paper out here just to kind of go over the things. Let's do x minus 1 over x plus 1. It's easier to write it like this than, they have it all on one line with just a division symbol between it. But this is what they mean. So let's see. We want to know y-intercepts. We want to know zeros, which is the x-intercepts. We want to know horizontal asymptote, vertical asymptote. And was there anything else that we looked at on there? Let's see. Y-x, vertical, horizontal. Okay. Y-x, vertical, horizontal. Okay. Let's see if we can figure those out. So we said the y-intercept happens at f of 0. So f of x equals. So let's calculate f of 0. 0 minus 1, 0 plus 1. That's just substituting 0 everywhere there's an x. Negative 1 over 1. So the y-intercept is at 0, negative 1. Because when x is 0, y is negative 1. So that gives us the point 0, negative 1. That's the y-intercept. Where's the zeros? The zeros is where the numerator equals 0. X minus 1 equals 0. Add 1. Remember, this is for, they don't have anything in common. Remember, if there's something in common, we have a whole. These don't have anything in common. So the 0 is at 1, 0. X equals 1, and the y equals 0. Horizontal asymptote. Remember, with the horizontal asymptote, we have to look at the degree of the numerator and the degree of the denominator. If the numerator is larger, there's no horizontal asymptote. If the denominator is higher, it's y equals 0. But when they're the same, which in this case they're the same, we just look at the coefficients. And what's the coefficients? 1 over 1. There's no coefficient of it, it's just 1. So the horizontal asymptote is at y equals 1. And the vertical asymptote is where the denominator equals 0. X plus 1 equals 0. Subtract 1. So the vertical asymptote is at x equals negative 1. So now we can graph it and check all of our answers to see if this is all right. X minus 1. There's x minus 1 over x plus 1. All right, first off, we said the y-intercept was at 0, negative 1. There it is. That checks out. We said the x-intercept is at 1, 0. There it is. That checks out. We said there's a horizontal asymptote at y equals 1. Oh, that is the horizontal asymptote. See the green line? And we said the vertical asymptote was at x equals negative 1. Oh, let's change that color. Let's change the asymptotes to both be red. That is the vertical and horizontal asymptotes. So this all checks out. It's good. So our lesson has 2 more problems that you can do that with. This one you have to factor it. X squared plus 4x plus 3. You have to factor that. It's a quadratic, so we know lots of ways to factor that. But you can check your answers. It's got the answer key right here. So all that good stuff. Oh, let's talk about slant asymptotes. We mentioned this and say, you get to college calculus or pre-calculus to study this. In a rational function where the numerator has a degree exactly 1 more than the denominator, The graph of the function has a slant asymptote. Okay, now we talked about when the numerator has a degree that's higher than the denominator, we said there's no horizontal asymptote. And that's true. But if it has a degree exactly one more, then it'll have a slant asymptote. We raise this to be x squared. The whole thing's a slant at that point because it cancels out. I need to change this like x plus 3 or something so it doesn't cancel out. See, now we can see that slant asymptote because we have x squared on the top and x on the bottom. It's exactly one more. If it's two more or three more, see, there's an x to the fourth, there's x to the third. We don't have any of that. But if it's exactly one more, we have a slant asymptote. Determine the slant asymptote can be accomplished using long division of the polynomials. If we divide x squared minus 4x plus 3 by x plus 2, we can find the slant asymptote. So let's actually go through the exercise. Okay, so we can find the slant asymptote. It says if we actually do the division. Well, since this is just an x plus 2, we can do synthetic division, right? So this is 1x squared, this is negative 4x, and this is a plus 3. So with synthetic division, we bring that down, multiply. Negative 2 times 1 is negative 2. Add negative 6. Negative 2 times negative 6 is 12. So we got a remainder of 15. But this gives us x minus 6 with a remainder of 15. X minus 6 should be the slant asymptote. The slant asymptote be x minus 6. There it is, dividing the numerator into the denominator. Let's put this actual equation here. Let's see, it was x squared minus 4x plus 3 divided by x plus 2. All right, I'm going to take out these other asymptotes we have. And it said the asymptote is y equals x minus 6. And it is. Look at there. That is the line that it's approaching. When we divide the top, even though we had a remainder, that didn't matter. We just took the x minus 6 part, and that gives us the actual slant asymptote. So that's pretty cool. Vertical asymptotes versus holes. Remember, if we have something that is the same in the top and bottom, like the graph of x minus 1 over x squared plus x minus 2, this x squared plus x minus 2 factors to be x minus 1, x plus 2. So you've got x minus 1 on the top and bottom. So that means at x equals 1 is a hole in the graph. Let's look at that again, just to remind us how that works. If we have y equals, and on top we have x plus 1. Oh, and on the bottom we have x plus 1, x minus 2. So what that was? X minus 1. Oh, it's minus 1 and plus 2. These are both minus 1. Minus 1, plus 2. Okay, we have this situation right here where there is an asymptote at x equals negative 2 because of the x plus 2. But we do not have an asymptote at the x equals 1 because it is a hole. There it is, undefined. There's a hole in our graph because the x minus 1 exists on the top and the bottom of our fraction. So that means if you set that equal to 0, x would be 1. 1 minus 1 is 0. That is not an asymptote. It's an actual hole in the graph. If this was x minus 2, suddenly it's an asymptote now, see? Because it doesn't have anything in common. But if it has the same thing in common, it's just a hole in the graph. There's a vertical asymptote at negative 2, but there's a hole at x equals 1. Okay, analyzing the graph a rational function. Based on your knowledge of intercepts, domain, symmetry, and asymptotic behavior, that just means it has asymptotes. If you want to impress your friends, work in the phrase asymptotic behavior. Means that it has asymptotes. It says, let's look at the function together and obtain its graph by hand. Okay, we're not going to graph it by hand, but we will know how it works. All right, load it up. Let's analyze the following curve. X minus 2 over x squared minus 4. There's the function they gave us. Right? X minus 2, x squared minus 4. All right, and we want to know like what the graph would look like. And so we do that by analyzing all these things. What is the y-intercept? That's when this equals 0. So we would say 0 minus 2 over 0 squared minus 4, which 0 minus 2 is negative 2. 0 squared is still just 0, minus 4. Negative 2 over minus 4 is 1/2. So the y-intercept is going to be 0, 1/2. X-intercept is going to be where the numerator equals 0. X minus 2 equals 0 happens at x equals 2, right? So 2 comma 0. We want to know horizontal asymptotes and vertical asymptotes. Horizontal asymptote. That's where we compare. We have an x to the first power. We have an x to the second power. The denominator is larger. So that means it's at y equals 0. Do it that way. And the vertical asymptote. Vertical asymptote depends on the denominator. Let's factor it. X squared minus 4 factors to x plus 2, x minus 2. Remember that was difference of squares? But we've got an x minus 2 in our denominator. These cancel out. So there is a hole. I'll add this up here to our information. Hole at x equals 2. Because x minus 2 is a whole. If you set that equal to 0, add 2 to both sides, it's at x equals 2. So since that cancels out, this will be our vertical asymptote, where x plus 2 equals 0. Subtract 2. Vertical asymptote, x equals negative 2. So if we graph this, we know at negative 2, there's going to be an asymptote. Be an asymptote. We know this is going to be an asymptote. And we know there's a hole wherever it's at 2. It's going to have a y-intercept at 1/2 and 2 zeros. We're just going to have y-intercept, x-intercept. So apparently, if that's an asymptote, it must go underneath it and come back up that way. And here, it's going to go something like that. So apparently this is one of those that touches, goes below the x, and then they'll come back and slowly rise close to the y equals 0. Let's take a look and see exactly what this looks like to see how close are we. X minus 2 over x squared minus 4. X minus 2 over x squared minus 4. Why do we not have? Oh, we don't have an x-intercept. This was wrong because we have to simplify it first. because it really simplifies to 1 over x plus 2 because this canceled out with the x minus 2 in the bottom. So it did not create an x-intercept. It created a hole instead. That's where I messed up. This will stay above that, but there will be a hole right here. There's a hole, undefined. But we do have the, let's see, where's the 1/2? There's the 1/2 y-intercept. Y equals 0 was an asymptote. And x equals -2. We have x equals -2? Yes, we did. -2. I wrote it. I was just looking to see that I'd only written down 2 up here. It's like, but it is a negative because when I calculated down here, it had a negative. I just forgot to write the negative up here. So y-intercept, horizontal asymptote, vertical asymptote, and the hole at x equals -2. And this is not true because you got to simplify it first before you check the numerator. And since the numerator is just a 1, there's no x-intercept. So that goes through all of that. So the x-intercept, again, had to be reduced first. 0 equals 1 over x plus 2. There's no x-intercept. You got to use the reduced form to find the intercepts. Let's see. All right, it just says go to Desmos to graph it and confirm. All right, I like it. This gives some more. Use synthetic or long division to find the slant asymptote. And this you can use synthetic division, divide by 1. You can use synthetic division, divide by 2. This one you need to use long division because you can't do synthetic division if you have an x squared. You can only do it when you just have an x. You can check your answers on there. So, but that is the lesson. Then it gets down to the more detail. Like I said, we usually just look at the scenic overlook, and then it repeats down here with more details. So this talks about how you have to factor the denominator, analyzing the graph of rational function. This will go through the same things we looked at up there. Look at the domain and range. Let's see if there's anything down here we didn't really talk about. The end behavior, we've discussed that a lot. The end behavior, whether they would go up or down. So you do that by first simplifying it, like they did the division. This one's ends up to be an x squared, so it's going to be a parabola. Analyzing the graph. So, okay, let's look at the assignment we have this week. This assignment is a little different. Print this page or just copy it onto paper. You can copy a graph onto paper. And you are to find the domain and range, the x and y intercepts, and the asymptotes. Here's a blank graph. If you have a printer and want to print this out, that's great because that would be pretty simple as well. In fact, I think we go, no, it doesn't have it on. It doesn't have it on. But here's what you're filling out. If you want to do this, just copy it on paper. Here is your equation. Tell me the domain and range, which after you graph, that'll be easy to see. You know, asymptotes are not part of your domain, are not part of your range. What's the x and y intercepts? What's the horizontal asymptote? What's the vertical asymptote? Draw the graph. Same thing here. Draw the graph. 2 problems. Do it on a Google Doc or something, or take a picture of it on paper. Turn it in at the bottom. Scroll to the bottom to submit. Turn it in down here. That is the whole assignment for the week. 2 problems where you're finding those asymptotes, those x and y intercepts, and the domain and range just means all x's except x cannot be -2, right? Because that would be a vertical asymptote. or it's a whole, or maybe x can't be -2, or it can't be 5 because maybe there's a whole and an asymptote. So that's all that we have this week. That is the last lesson of the year for this class. For those of you who are not seniors and back next week, we're going to do the golden ratio project. That's not so much of a lesson as it's a project we're going to do together. It's kind of a fun thing. Last assignment for non-seniors. And then we got the semester final. So seniors, if you are not exempt, I'll be emailing out as soon as I get the attendance report. So I expect no later than Thursday. I'm hoping tomorrow that I get the report early enough to be able to go through that. So I'll be looking at everything else, missing assignments. Make sure you got 75%. I'll have everything ready for when they send me the final attendance report. So then I'll know advisory, attendance, and all that other stuff. So we're right at the end, guys. It's May. When it stops raining, go enjoy some weather. Yeah, the rain is not going to last forever. And if you got questions, I'll be here in class Thursday. So otherwise, have a great week, everyone. We'll see you next time. You got the rest of the class to work on this assignment.